Hey, this is Mr. James. In this video we're going to be talking about the converse of the Pythagorean theorem. But before we get started, it's important to know what the word converse means. Now remember from the beginning of the year that converse is when you switch the hypothesis and the conclusion, or the beginning and the end, of a conditional statement. In a sense, you're taking a regular statement and just reading it backwards. But how does this make sense with the Pythagorean theorem? Normally when we think about Pythagorean theorem, we think about having a right triangle, such as this one right here, and knowing two sides of it, for example, these two legs, and being asked to solve for x, in this case, the hypotenuse. In this case, we start with the fact that the triangle is a right triangle, and we figure out one of the sides using the Pythagorean theorem. Remember, a squared plus b squared equals c squared. On the other hand, we could be told that we already have the side lengths. We already know that this triangle has side lengths of 6, 10, and 15. And we're not going to try and figure out any other side lengths because we're already given them, but instead we're asked, is this a right triangle? This is called the converse of the Pythagorean theorem. Because normally we would be given that it was a right triangle to start and then solve for one of the sides. But in the converse, we are given all the side lengths and asked, is it a right triangle? Let's see how that works. We'll start by looking at Pythagorean triples. A Pythagorean triple is a set of three integers that could form the sides of a right triangle. So number one, is 3, 4, 5 a Pythagorean triple? Could those be the sides of a right triangle? Well, let's see. If this was a right triangle, 5 would have to be the hypotenuse across the right angle because that would be the longest side. And 3 and 4 would be the sides of the two smaller legs. So what we can do is we can write down the Pythagorean theorem, a squared plus b squared equals c squared, and substitute in these values. Remember, 5 will have to be the c, the hypotenuse, and a and b will be 3 and 4 respectively. Now I'm not going to put an equal sign here, but I will put an equal sign and put a question mark on it because I'm not sure if those equal each other yet. If they equal each other, then the Pythagorean theorem is true and this is a right triangle. But if these two sides do not equal each other, then the Pythagorean theorem is not true for this triangle and this is not a right triangle. Let's see. 3 squared is 9, 4 squared is 16, 5 squared is 25. Again, they're not equal, but I'll put a little question mark here. 9 plus 16 is 25. Bring down this 25. Then yes, these are equal. I can't put an equal sign there. No question mark needed because I know that a squared plus b squared does equal c squared in this case. That means that yes, this is a right triangle, and this means that these three numbers are called a Pythagorean triple. Yes. Let's take a look at number 2. Is 6, 8, and 10 a Pythagorean triple? Well, again, if I had a triangle with side length 6, 8, and 10, 10 would have to be the hypotenuse, 6 and 8 would be the smaller legs, and I'll just set up the Pythagorean theorem here. 6 squared plus 8 squared. Does it equal 10 squared? I don't know. Put a question mark there. So let's simplify. 6 squared is 36, 8 squared is 64, and 10 squared is 100. Again, I'll put the question mark there because I'm not sure if they're equal yet. Add those together, you get 100, and 100 equals 100. That means that the Pythagorean theorem is true for these three numbers, 6, 8, and 10, and yes, this is a right triangle. But actually, there was a slightly easier way to do this problem. Look back at number 1. We had side lengths 3, 4, and 5. In number 2, we have side lengths 6, 8, and 10. Do you see a pattern? All of the side lengths in number 2 are double, or times 2, the side lengths in number 1. Think back to our previous units. That means that these two triangles are similar. And if two triangles are similar, that means all the angles are congruent. So if this first one is a right triangle, if we simply double all the side lengths, then this one will also be a right triangle. 6, 8, and 10 must be a Pythagorean triple because it's just double the first Pythagorean triple, 3, 4, and 5. At this point, try pausing the video and doing 3 and 4 yourselves. The answers will be up in 3, 2, make sure you've paused, 1. Alright, so let's take a look at 3 first. We had a 9, 12, 14 triangle. So I drew a little triangle here and I put my numbers into what looks like the Pythagorean theorem. But it turns out that 225 for the a squared plus b squared, we get 196 for the c squared. Those are not equal to each other, and so this is not a right triangle because after substituting those sides in, it did not work with the Pythagorean theorem. So no, this is not a right triangle. And we could have told this another way. If you look here, 9 is 3 times 3. 12 is 3 times 4. So it looks like these triangles are similar, right? This number 3 is just 3 times as large as number 1, except 14 is not 3 times 5. So this triangle is not similar to our previous 3, 4, 5 triangle, and so we know right off the bat that it's not going to be a right triangle. For number 4, 5, 12, 13 does turn out to be a right triangle. It's not similar to 3, 4, or 5, but in its own right, it is a Pythagorean triple. 169 equals 169, so yes, that forms a right triangle, and we can even put a right angle on our drawing. At this point, go ahead and try number 5. List other possible Pythagorean triples. As a hint, all you need to do is take one of the previous Pythagorean triples we've found, like 3, 4, 5, or 5, 12, 13, and multiply all the sides by a certain number to get another similar right triangle. Go ahead and try that by pausing the video now. The answers will be on the screen in 3, 2, 1. Please make sure you actually tried this one. Here are a couple of Pythagorean triples that I've written out. 9, 12, 15 is actually this 3, 4, 5 all multiplied by 3. 12, 16, 20 is again a 3, 4, 5 multiplied by 4. 10, 24, 26 is just a 5, 12, 13 multiplied by 2. And 8, 15, 17, I looked that one up online. If you just Google search Pythagorean triples, you'll find a whole bunch that work. Quick side note, a 3, 4, 5 right triangle and a 5, 12, 13 right triangle appear a lot of times on quizzes, tests, SATs, college tests, things like that. So it's actually sometimes really helpful to memorize that 3, 4, 5 is a right triangle and 5, 12, 13 is a right triangle, because those are some favorites that you'll see on big tests. At this point, what we can do is we can use the Pythagorean theorem to determine if a triangle is right, obtuse, or acute, or maybe it's not even a triangle at all. To start, what I'd like you to do is for problems 1, 2, 3, and 4 at the bottom, do exactly what we did before. Use Pythagorean theorem to test to see if they're a right triangle. Once the work is on your paper for problems 1, 2, 3, and 4, unpause the video and we'll talk about how we can use that work to figure out if a triangle is obtuse, acute, or if it is a right triangle. Please try problems 1, 2, 3, and 4. The answers will be on the screen in 3, 2, did you really pause it? Double checking. And here are the answers. 3, if you need to, pause now to check what you've done. Let's hop in and start analyzing this. So for the first one, we've got a triangle that's 10, 24, and 26. Remember, 26 is the longest side, the hypotenuse. So we set up Pythagorean theorem, 10 squared plus 24 squared equals 26 squared. And we simplify and find out that both of those sides are equal to each other, which is good. That means Pythagorean theorem works here. Check. This is a right triangle with a right angle. So this is a right triangle. One's pretty easy. But the second one's a little different. In this case, we have a 3, 3, 4 triangle. And so when we put this into Pythagorean theorem, 4 being the longest side, we get 18 for a squared plus b squared, and we get 16 for the c squared. They're not equal, so it's definitely not a right triangle. But we can say even more than that. Notice how the a squared plus b squared is larger than c squared. That means the hypotenuse is smaller than it needs to be. The hypotenuse, the c, is smaller than it needs to be. So a right triangle, this 16 would have to be an 18 to be 18 equals 18, but it's too small. So what does that mean for a triangle? Well, it means that this hypotenuse right here, the long side, is actually smaller than it should be. So let's shrink that and connect this to see what it should look like. If the hypotenuse is too small, what kind of triangle do we get? Well, we get an acute triangle. So our 3, 3, 4 triangle is actually going to be an acute triangle because the hypotenuse is too small compared to the other two sides. What about number 3? Well, number 3, we've got a 3, 8, 9 triangle, and so we use Pythagorean theorem here. We find out that the a squared plus b squared is 73, and the c squared is 81. This is different. It's definitely not a right triangle because these two do not equal each other, but in this case, the hypotenuse, the c squared, is larger than the other legs, the a squared plus b squared. So the 81 is larger. What does that mean for our triangle? Well, if the hypotenuse is longer than it should be, let's pull this out a little bit, make it a little longer. and connect the other side, then what kind of triangle have we created? Notice the obtuse angle created right here. This is obtuse. Again, because the hypotenuse is larger than it should be. So we figured out that if the hypotenuse is too small compared to the a squared plus b squared, it's acute. If it's too big, it's obtuse. But what about number 4? Well, number 4, we have a 3, 8, 14 triangle. And if we use Pythagorean theorem here, we see we've got 73 for the a squared plus b squared and 196 for that c squared. So clearly, the c squared is larger, and it looks like this is going to be an obtuse triangle. But hold on a second. What would this look like on our triangle over here? Let's think about this for a second. If the hypotenuse is really 14, it's going to be quite long compared to the other sides. In fact, it's going to be so long that even if I took the other two sides and stretched them out completely, like this, they wouldn't even stretch the other side. Think about that for a second. 3 and 8, well, 3 plus 8 is only 11. And so even if I laid these two other sides out completely, they would never be able to connect to this other side because it's 14. 11 can never catch up to 14. So this is more than obtuse. If you have a triangle where two of the sides add up to less than the third side, that's not even a triangle at all. This can't be a triangle. Again, if one side is longer than the sum of the other two sides, then this cannot be a triangle. Because remember, if the longest side is longer than the sum of the other two sides, the triangle can't even connect to make a closed figure. It won't work. What I'd like you to do now is take a look at number 5. If A, B, and C are the side lengths of a triangle, and C is the longest side, then fill in these 4 blanks with words we've used before, such as right, obtuse, acute, or not even a triangle. Go ahead and fill in the blanks now. The answers will be up on the screen in 3, 2, make sure you tried it. Here they are. If a squared plus b squared is less than c squared, that means c squared is too small, then it's going to be an acute triangle, just like we saw in number 2. If a squared plus b squared equals c squared, well, that's Pythagorean theorem. That means we're going to have a right triangle, like we saw in number 1. If a squared plus b squared is less than c squared, that means that c squared, the hypotenuse, is larger than it should be to be a right triangle. It's going to be a big obtuse triangle with a big angle there. And if c squared is so much bigger than a plus b, that it won't even be a triangle, because if the longest side is longer than the sum of the other two sides, then the triangle won't close. Kind of like this. It'll be too long. It won't even close. That ends the video on the converse of the Pythagorean theorem. Make sure you rewind if you need to see anything again. Good luck.